Hey everyone, in this video I'm going to walk through just the 2D SVG workflow that we worked on in class, and I'll talk in more detail about some of the specific things that you need to pay attention to in the Bantam Tools software. And so the first thing, with our machine we have the PCB mill, so yes, it can cut different materials as we talked about, but for this assignment this week, I want you to just focus on using the PCBs because they're really easy to use and we have lots of them, and they're pretty quick to cut. So you want to make sure you are using the Legacy version of the software for this project. If you happen to download the new version of the software here, it requires a subscription to do certain things, and it also requires us to update the firmware on the machine, which I don't want to do just yet. And so the interface in this Legacy version is much simpler too. It basically takes care of just the things we need it to do, and the new software does a lot more. So for this project, again, just use the Legacy version, and that's version 1.2.3, and it looks like this. So if you're opening this and it looks totally different, you're in the wrong tool. So make sure you have this tool, and you should be able to get your thing cut. So I'm going to just kind of walk through the same workflow we did in class, but talk about some more of the details here so you can see them. And I'm not connected to a machine, of course, so when you connect to the machine, the interface might look slightly different, and it's going to give you messages on the bottom, sort of guiding you through the process of using the machine. And there will also be a little bracket that shows up on the front right here in front of your PCB. So don't worry too much about that. That's more of it's an alignment bracket, and it's installed to make it easy to place a PCB on the bed. And so, excuse me. So it should reflect what the machine looks like inside. And I believe I left a piece of material on the machine, on the bed, before I left the other day. So half of it, the other half of it, could actually be used. So let me actually open up the project that I used for that to just kind of show what it would look like, and then we'll walk through the workflow. So the project we did in class was this one, and I saved the build file. It looked like this. So we didn't actually cut it out, so this red box does not exist on the piece that's actually cut, that's in the machine. What that means is this right side right here, this empty area, could be used if somebody would like to use it. Or you can just take this off of the machine and put a fresh board on. So I'm going to do, let's see, new file here, or close this one and open it again. Bantam Tools. Okay, so here's where we start. So when you open the tool, you should just see, I believe it's a PCB like this. If it's not, up here on the right side, this is where you configure everything for the most part. So it might show something blue like this. This is basically just a generic piece of stock material of unknown type. So it could be wood, it could be metal, it could be plastic. You don't really indicate any of that here. It's just sort of, it says generic. So what you want to do for this project, and right now, is just use the single-sided FR1 material, which is just the circuit board. And it's basically ready to go after you pick that, and then you pick the standard size. So 5 inches by 4 inches by 0.061 inches. And this might be initially in, I think in millimeters, and if it is, you just have to go under view and toggle it, show units in millimeters or show units in inches. And so it might look like this, and it's just easier to work in inches for this stuff because we're used to inches. So toggle that, make sure it looks the same as this, and then make sure your placement is also at the origin 0, 0, 0. And so again, there'll be a bracket right here when you plug in the machine and see it. And up here it should say under fixturing, it will say alignment bracket, I believe. So this will be the same, 0, and the origin will still be basically right about here on the build platform, just inset a little bit, but that will be considered 0. So after that, you don't need to configure anything else with the material. It should be ready to go. Now you need a plan. So if I click open files, and I'm going to grab my file from the other day, my hexagons again, and just import that. By default, it might try to assign a couple of tools, 1/8 inch and 32nd. You can go into there and click none on all of them if you would like to start, and then you won't have any tools there. And in this version of the software, you won't show any paths or anything to cut until you add a tool. So I'm going to toggle off the cutout in a second, but what we can see here is I imported my file, the placement is at 0, 0, 0, and the scale is 100%. And so first thing is, let's grab a tool. Say I grab the 1/32 flat end mill, and I just kind of look at my file here, look up close in the top view. We can see, okay, there might be a few areas where it's not going to cut out. Anything that's red and should be cut out, which we can see like this in these areas, it's saying it's not going to cut it out. I know for a fact that these lines are 1/32 of an inch exactly, and so what's happening here is there's actually a different, probably a slightly different size entered in the tool library for that specific tool, and we can change that or bypass it by using a different tool. And then I also noticed that there's a cutout happening on this board, and I don't really want to cut this one out unless I'm ready to take this board or cut this piece away from the larger piece. So I'll just toggle that off, and what that does is it still shows a border like this, but it doesn't actually, it's not going to cut anything unless I actually say cutout. And the way cutout works is it's looking for, the software is looking for a closed boundary around something, your SVG artwork. So in Illustrator, if you have your file set to like a 3x3 inch artboard, it will consider the outside, as long as there's a path there, a square there, it will consider it the boundary, and it'll automatically add the cutout option right here. So you want to just toggle that off if you don't want to cut it out right away when you run your job. And you also want to make sure that if you do cut something out, you want to make sure that maybe the placement of the design is inset a little bit, so you want to give yourself some room. So like I would put this in about 1/8 of an inch by adjusting the placement. So 0.125, 0.125 in the X and the Y. And so that moves my entire design in a little bit from the edge, because you don't really want to cut along the edge, because you could potentially run into the little alignment bracket that's sort of a U shape on the bottom of the build platform and on the left and the right. So just be aware of, if you're going to cut something out of the board, which you don't have to, you could just focus on engraving in the board if you like, but if you're going to cut it out, you want to make sure you put the boundary in a little bit, give yourself some room around it. So that's the placement. And so to kind of solve this problem of these things being red and not cuttable, I'm going to actually pick a different end mill that I have in here, which is 1/32 flat end mill FR1. So it's slightly different in terms of the parameters that are used for that tool, and you can see it actually works a little bit better than the other one I selected, and it's just because of some settings. The visualization should reflect what happens in reality, but sometimes, depending on the way the tool is configured, it doesn't actually visually show it in here the same as it would cut it on the machine. On the machine, it might actually still go through those areas that are a little bit red, but as you could see, if I change it again, look at the time. So this is 2 minutes and 24 seconds. This other one is moving much slower, and it's also the diameter of the bit that's specified in this tool is probably slightly different, which is why it's showing these red marks, and it's actually moving slower. So 5 minutes and 42 seconds. So it takes longer to run with this bit choice versus this other bit choice right here. And so I'll point you to the library in a second, but once you have your milling tool chosen here, the engraving depth is typically about this, 0.006 inches. And that should be a good depth for just cutting a pattern into a surface like this. And you don't need to do anything under advanced right here. These are other options, like you can invert kind of where it's going to cut. You can tell it where it's going to cut on the outside line, like if you were to cut on the inside or outside or on the center of the line. So let me add cutout back in so we can zoom in here and see. Oops. So if we zoom into the outside, the perimeter, and change this outside, it's going to keep basically cut outside the shape, so you'll get a perfectly square 3x3 inch shape or whatever your dimensions are. Or if you go to the center, it'll go along that line, so it'll be a square shape, but it'll be along the center, the curve, the path itself, and it will mean your shape will actually be a little bit smaller than what you intend. And then if you go inside, it'll be the inside, it'll run inside of the line that you defined, so it'll definitely be a little bit smaller. Then it'll be a 32nd of an inch smaller inset from each edge. So if I zoom out and zoom into another edge, you can see that. So that kind of thing matters when you're dealing with really tight fitting things like circuit boards within electronic devices. And so for this, in this case, we're not going to worry about cutting it right now, but toggle that off. It still shows a red line because it indicates that it's there. So after this step, what you do is home the machine, make sure your tool is in there, and you would click Start Milling once the workpiece is in there and everything is set up correctly. Issues that you could run into with this process are going to be things like scale, mostly. Like if you create a file in Illustrator and it's too big, say I make this thing 150% scale, you could run off of the board right here, in which case that part of your design will not be cut correctly. You want to make sure when you import something in here that it's at 100% scale, and that the size of the path that you're going to engrave, the artwork itself, matches what you're designing in Illustrator. So in Illustrator or in Rhino, wherever the files are coming out of, you want to make sure your SVG file has the thickness that you need for filled in areas, and you want to make sure it's not going to run over the edges of the board. If you need to make something that's larger than the size of this board, then you have to plan for that. You have to plan out how it's going to overlap. So say I did make this thing 150, and I could basically get this to fit on this board, knowing that I wouldn't cut it out, by going in my Y direction and just shifting the whole thing down. So if I set this to 0, we can see, okay, it goes down a little bit. Maybe I go to minus 0.125, and we're on the edge a little bit. Maybe I want to go minus 0.2, just to go a little bit more, minus 0.25. So we can see this is sort of inset from the top and bottom edges of the board now. And still, if I were to cut this out, maybe I'd want to cut along the perimeter of the hexagons themselves and make something that could tile with another thing. I would have to go back into my Illustrator process and define a curve or a path that goes around the outside, and then in here I would click cutout and it would add in the cut line around the outside. So again, you don't need to cut something out. If you just want to focus on engraving a pattern, that's fine too. And so kind of the last thing I want to show you is where to get additional tool definitions. So just to save you time, so under File, Tool Library, This is where you can define tools manually, or you can import and export tools. By default, the Bantam Tools, the software comes with, I think it comes with kind of these basic sizes over here, like 1/4 inch, 1/8 inch, 16th inch, 32nd, 64th. I think it comes with these top 1, 2, 3, 4, 5, 6, 7, 8, 9 or so bits. And then anything after that is stuff that I've added on my machine, I think. But you could start totally fresh and delete everything if you wanted to, and import all new tools. But this is where you manage them. You would come in here and you would click import, and you would upload a file. And so where you get that file is dependent on the material you're using. So to find, let's see, I would go under, I believe, all materials. So under their material library on the website, I believe you can get to the PCB materials by going down to the blanks. And let's see if it's on here. It's possible it's in the support section. So that's the data sheet for it. I think it's under Support Center. And we'll go here and just see if we can find, so set up your material options. So maybe under material options, FR1 PCB blanks. Okay, so this will tell you everything you need to know about the material and other materials, but specifically the PCBs, and you should read through this. They talk about how to stick it down to the bed, just like we did in class. They talk about which bits work well with this material. There's an example project where you mill out this little rooster board that lights up if you have the electronics for it. And then down here they have recommended feeds and speeds. So this is what you want to look for, and you want to then look at the tool size that you're using, and you want to match up the feeds and speeds they have here. These are the recommended feeds and speeds, and they do this so you sort of start slow and you don't go as fast with the machine, but it takes more time to cut something out. So if we were to use this right here, these settings, I could go over to my tool library here and manually add this. So if I were to manually add a new tool, I would click add, and it says no name, and so I can go 1/32 inch flat end mill. I'll just call it demo for now, and so I can separate it from my other ones. And you pick which type of bit it is. If you change this, it's going to change the picture here. So flat end mill is what we're working with, and then the diameter of the bit. The resolution of this is only three decimal places to the right, so 1/32 is 0.03125, so that's why it shows 0.031 here. And then what you want to do is you can see in here they fill it in automatically, the speeds and feeds that are matching what's on the website here, and that's okay to use. And what you can do is use this, and let's go back here, close this, and I'm going to go back here and pick that tool that I just added, if I can find it. 1/32, where is it? Did I save it? Let's see, tool library. So I'm going to actually move it. Can I move it? I don't think I can move it. 1/32 flat end mill. I'll toggle custom and just leave it like that and see if that helps. I believe it should just show up in here. Maybe I'm just not seeing it. Oh, there it is. 1/32 flat end mill demo. So if I pick it, we should basically see the same result that we expect here. I'm going to change this back to 100%. So you'll see, okay, there's some areas where there might be issues, but I think it would work. And so what you'll see is 5 minutes and 42 seconds. So that's a good time frame for a pattern like this. If I go back into the tool library and go back to my tool, go speeds and feeds, I can actually change these as I sort of discover more about the material and how it performs in the machine. So if I wanted to make it go faster, I could increase the feed rate a little bit. And if I wanted it to move in the vertical direction and plunge down into the material faster, I could change this. If I wanted to change how fast the spindle was spinning, I could change that parameter right there. And then the step over and pass step you usually want to just leave as is. So if I wanted to make this process go faster, I could go back to my sheet here and scroll down and look at the advanced feeds and speeds. And so what this is saying is you need to be somewhat familiar with how feeds and speeds work before you try these settings, because it means the machine is going to go faster and spin faster. And so when things move faster, you're more likely to break something. And breaking things is fine, it happens, so I'm not too worried about that. But you want to just be aware of what you're changing when you're changing it. So if I go back to my tool here, I can then change these values that it shows to right here. So tool 1/32 flat end mill. Again, this is for the PCB. I could change this to 59, the feed rate to 59 inches per minute. So I could just go in here and say, okay, this is 59. And you'll see that's like a pretty big increase. That's almost it's about 4 times as fast. So that means it will go faster. Plunge rate, 15. Let's change it to 15. And spindle, 16,400 RPM. So 16,400 RPM. And then the max pass depth is 0.006, which is what it's set to here. And this is the pass depth is how deep the drill bit is going to cut into the material per pass. So think about it kind of like 3D printing, but in reverse. In 3D printing, you're adding material on top of itself. In CNC milling, you're subtracting material from a block of something. So it's removing this much material each pass if you were to cut down deep into a piece of something. So in this case, it's one pass where it's cutting material. It's only going as deep as it's told to right here for that layer in the plans. So that's all good. And in your tool library, you can go ahead and customize as many tools as you want and need to. I would just focus on using one tool. Let me go to the tool that I was picking here that was making the time better and working best with this material. So when I change those parameters, we can see actually over here it updates the milling time right away. So you can see 1 minute and 45 seconds for this board now instead of 5 minutes and something. If I go to this one, 1/32 flat end mill FR1 that I have, there's a slight difference in the feed rate, so it's a little bit slower. It's not 59, it's 43. The plunge rate's the same. The spindle speed is much faster, I believe, than the one that it shows here. So this is 16,400, and I have 25,000 RPM here. So that's just moving the machine much faster, and the pass depth is actually deeper too. So this was actually the setting that I used in class to demonstrate the machine, and it was around 2.5 minutes, I believe, to run it. Let's see if I change this, then I can see what the time is. 1/32 flat end mill, 2 minutes and 24 seconds. So go back to our demo one here. So you have the ability to change how much time it will take the job and how detailed it will be when it's cutting. And again, sometimes the display that it shows in here doesn't reflect exactly what it would cut out, but it's 99.8% accurate. So just be aware that there's always little things like that that can pop up. But for the most part, it's pretty right on. So I would follow the guidelines that it shows right here on the website as far as the recommended, the 1/32 right here, 1/32 recommended feeds and speeds, and let it take a little bit more time to cut it out at first. But then as you get more comfortable, try tweaking the settings as it shows here. I think 59 might actually be a little too fast, but that's what they recommend as sort of an advanced feed rate. But I would just keep it down around 40 to 45 inches per minute if you want to increase the time, increase the feed rate to decrease the amount of time it takes to cut it out. So go and close that. And another thing you can think about too is if you have a project where you have multiple designs, you can add additional designs to this sort of stack right here by clicking Open Files and just adding in another file. So like if I go to, let's see, the triangle example that I showed a video of, and I go to the SVG file, I think it's this one, and I import that, then what we'll see here is another layer show up. So I have my hexagons, and then I have this triangular grid, and I'm going to turn off the 1/8 inch bit and just let the 1/32 flat end mill show up. So placement, again, like you can't drag designs around on the board, you have to numerically place them. So say this is probably like 2 inches over, maybe even more, 2.5, 2.75. Well, that works. So this design currently is too big for the board, like they both run off since they're next to each other here. I'm sure with more fiddling I could get it all to fit on this board, but I'm just mostly demonstrating how you can import multiple layers. So yeah, so right here, toggle cutout off, and I can see multiple files on the same board. If I click this little eyeball, I can actually just hide that one and say I just want to look at this one in place over here to kind of plan out, you know, where it's going to go, 0.125, 0.125 on the board, and not see the other layer. Then again, the settings are all what we did before. I would go down here and maybe pick this 1/32 flat end mill and see it'll take 8 minutes. Let's go to our demo one, which is faster, and it'll take 7 minutes and 35 seconds. So again, you have to find a balance with how long something will take and how fast the machine will run. So which is dependent on the material you're using and the bit you're using. So there's a lot of sort of factors at play here, but those are the big things. So with that, I will end this video, and let me know if you have any questions on the project this week. I'm happy to look at files before you run them and just double check all the features and details that are present in your file. And so the best way to share a file like this is to just save, go to File, Save Plans, and save a, let me see, desktop. I'll just say, hello project. Click Save, and what it's going to do is save a BTM file, a .btm file, like this. So you could send me this file, and I can open it up on my side and look at the design. And if you need to send the SVG file too, I can look at that as well to just double check things like stroke weights and placement, and if anything looks like it won't cut out. So that's all I have.